A progressive wave moves past 2 points P and Q, separated by a distance of 0.9 meters. A graph showing how the displacement y at P varies with time is shown below. So displacement versus time. Another graph shows how the displacement of the wave at time t equals 0 varies with distance x from the point P. So this is a displacement versus position graph. Using the data from the graphs, deduce for this wave the wavelength. So we have 1, 2, 3, 4. 4 lambda is 1.6 meters. So the wavelength will be 0.4 meters. Deduce the frequency. So this is a 4 period, 1, 2, 3, and 4. So 4 period is 5 milliseconds. So the period is 1.25 milliseconds, and the frequency is 1 over t. Let's say 100 Hz. Deduce the speed. Speed is equal to frequency times wavelength, so there will be 320 meters per second. Deduce the phase difference between the oscillations at P and Q. Now the distance between P and Q is 2¼ wavelength, so the phase difference will be 2¼ wavelength divided by lambda times 2 pi. So a distance of 1 wavelength corresponds to 2 pi radians in phase angle. So now we have a 2¼ cycle, and so we usually quote the phase difference between 0 to 360 degrees. So answer will be 0.5 pi radians. Deduce the ratio amplitude at P divided by amplitude at Q. So the amplitude will be 4:1. The intensity is proportional to amplitude square. So we have the ratio as 16. Light waves, sound waves in air, and surface water waves are different from forms of waves. Suggest with reason which of these might be the wave being considered in A. Now the speed of the waves is 320 meters per second. The amplitude is only a few millimeters. So this cannot be light because the speed is too small. It cannot be water waves because the amplitude is too small. So therefore it's sound waves, as the speed and amplitude are consistent with those of sound waves.